Hi there, everybody. So this is your first flip lesson. We're currently working on our transformations unit in our geometry class. We have three types of transformations. We have reflections, which we did before we went on break. The next one we're working on is called translations, which is what this video is over. And then the third one, which we'll go over our next time, is called rotations. So one way to help you visualize everything that we're doing here is excuse me. One way to visualize this is everything that you guys can do in a game of Tetris. We're looking at the math of how you move those pieces around in the game of Tetris. Is one way to visualize everything that we're looking at. So what we're going to look at here first is, here's what a translation is in general. A translation is taking a shape. So let's start off with setting a shape. So you'll need to write down these coordinates. Coordinate A has the coordinates 1, 1. So your first point is 1, 1. Your second point will be B. It has the coordinates 3, 1. And then your third point is C, which will have the coordinates 4, 3. So you guys can go ahead and write those down really quick. Let me zoom in here just a little bit. Okay, and we'll connect the dots, and we end up with a triangle. Yay. So when we're doing a translation, what we're going to be doing is we're going to take this shape, or whatever object it is we have, whether it be a point, whether it be a triangle, square, whatever it is. We're going to take that shape, and we're going to slide it. So it'd be like taking this exact image and moving it from this quadrant, moving it over to the second quadrant, or moving it across two quadrants and moving it down here diagonally, or dropping it straight down. It is a rigid motion transformation, so it's going to maintain all of the angles and it's going to maintain all of the side lengths. So it'll be exactly the same image that we're looking here. Unlike a reflection where we end up with a mirror image of the object that we started off with, we will have the exact same image but moved somewhere else in the coordinate plane when we do it. So let's see here. So we have our triangle coordinates. Let's talk about our rules for translations, and then we'll actually do an example of this. So we'll switch over to here really quick. Our rule for translations, you guys are going to see notation written like this. It'll be a capital T, and then kind of like the reflections when we were doing reflections. So when we had reflections, and then whatever our line of reflection was written in subscript. Similarly with the translation, you're going to have a translation, and then you're going to have these things that look like, these are actually arrow brackets, or what they're called, and what you will have here is the change in X for your first number, and then the change in Y for the second number, and then what will go over here will be whatever the object is that you are moving. So in this part here is going to be in subscript. So it'll be read as the translation of whatever your change in the X coordinate is, and then whatever the change in the Y coordinate is, and then your object. Okay, of whatever your object. So if we go back to our graph sheet here, so we're dealing with this object here. We have this object. This is the triangle ABC. We have our points here. We are going to do this translation. Let me move this over here. So we're looking at the translation. This is the translation -4, 3. So what this means is every coordinate has got an X coordinate and a Y coordinate. All of the X coordinates we are going to reduce by 4, and all the Y coordinates we're going to increase by 3. Okay, so let's go back here really quick here. So our change in X and our change in Y, we are all... stop it. Just a second. There we go. Here we go. We are always going to add. Okay, always going to add when we do these changes. Whatever this change is, so if it's a negative X, so we have a negative number here, then that means we're going to add a -4, and you do that appropriately. If it's a positive Y here, it means we're going to add that positive number to our Y coordinate. So if we come back here, we're going to add -4 to all of our coordinates, and we're going to add 3 to all of the Y coordinates. So if we start with A here, A is at the point 1, 1. If we add -4 to it, we get 3. We get -3. And if we add 3 to 1, we get 4. So that gives us this coordinate for our A prime. Okay, so we added -4 and we added 3, so we get -3 and 4 for our point. Okay, so we're going to do the same thing with the other 3 points for A, B, and C. You guys can do the calculations for these on your note sheet. So B prime will be here, and C prime will be over here, and then we will tie them all together, and we get our triangle A prime, B prime, C prime for our first translation. Okay, so we've taken this original triangle and we've just shifted it up into the second quadrant. Okay, we're going to do the same translation again. Now, in prior examples, when we started using like A double primes and stuff, it was because I was using it as a name, and I didn't want to do anything with, like when we were doing reflections, we used A double prime to just show this is our second reflection. We're going to start being a little bit more strict now with our notation here. Some people have asked me about this in class, so I'll acknowledge it here. When you start seeing A double prime, it typically means we have applied multiple transformations to the same object. So we're about to find A double prime, B double prime, and C double prime here in a second, and that's going to be the reflection of these points. So it's not going to be another version of our original triangle. It's going to be a reflection of this. I'm sorry, not a reflection, a translation of this triangle, of the green triangle. So, for our second translation, we are going to do this one. We're going to do the translation 1, -6. Okay, I know this isn't in subscript and it's not in the same format as what you guys saw on the previous slide here when we were talking about this. That's just limitations of what I can do with GeoGebra, though. So this is going to be, we'll take all the x variables, add 1 to them, and all the y variables, we're going to subtract 6. So I'll let you guys do those calculations as well. We get A double prime, which will be down here, B double prime, and C double prime. And we can connect those dots as well, and we get this purple triangle down here. So our first move is we took the red triangle, we slid it up to the green triangle, and then we took this triangle, and from this position, we slid it down to the purple triangle. And we can check our numbers on this again here too. So like for A is at the point -3, 4. So if I add 1 to that, I get -2. And if I add -6 to 4, I get -2. So that gives us the point -2, -2. Perfect. Cool. All right. So that gives our rule for our translations. Next thing I want to talk to you guys about is so we went from the red triangle to the green triangle to the purple triangle. Okay, the next thing that we're going to look at is what's called composition. So composition of translations is when we have multiple translations. And you're going to start seeing this notation quite a bit. You'll see it a lot, especially in this homework assignment that I have prepared for you guys. So what this reads as is the reflection of the across the y-axis given the translation of the change to of the point A is the way this reads. So I gave you guys this point 1, 1 here. There's an order to this when you guys are doing composition of translations. That's important, and that is that we read the composition going from left to right. So the first thing that we will do is we're going to apply the translation. We do this step first. You always do the one on the right first. So we'll apply the translation to, so that's going to give us an A prime of 3, 3. Okay. And then from there, we apply the reflection across the y-axis. If you guys remember that when we do a reflection across the y-axis, we just negate the x-coordinate. So that gives us an A double prime of -3, 3 for our final coordinate here for this translation. That's composition of transformations. Now we're going to get more technical with this later. We'll actually do a whole section on composition of transformations. What I want to concentrate on for right now is when we have 2 transformations. So if I have, in our previous example here, we have the transformation of -4, 3 that brought us up here, and then we have the transformation of 1, -6 where we took this object and we brought it all the way down here to the purple triangle. I want to know what happens if we do a composition of these 2 values, what we get for our coordinates. Okay, we already went from here to here to, we went from the red one to the green one, and then the green one to the purple one, and we ended up with the coordinates. Where do I have them here? We ended up with the coordinates -2, -2, 0, -2, and 1, 0. Okay? If you guys look at these numbers here, if we add them all together, let's concentrate on the point A. A is at the point -2, -2. Okay? If I add my change in x's together and my change in y's together, let's see what I get. So -4 and 1 added together gives me -3, and 3 and -6 together gives me -3. So that gives me this translation, which is the translation -3, -3. So if I apply this same translation to my original points, what do I get? So for A is at the point 1, 1. If I apply these points here, I will get -2, -2, which gives me this point right here. And if I apply the same thing to B, B is at 3, 1. So that'll give me the point 0, -2, which is this point right here. So, and then if we can do the same thing for C. So C would be will be 1 and 0. 1 and 0 when we do the math. So that gives us this point right here. So what I want you guys to take away from this here is that when we compose translations together, all we're going to do is we're going to add the change in the x's together and add the change in the y's together. And that'll give us a brand new translation that is the composition of these two translations. Okay, and it works in either order is the cool thing. So if we go back here to my example here initially, if this was a translation, if this was actually a translation and not a reflection, I could do them in either order and end up with the same translation rule. You guys will see that in the homework where you're asked to find the translation rule given a composition of transformations. Okay, let me see if I have anything else to add to this here. I think that covers everything for now. You guys have notation, you guys have triangular coordinates, and you guys have the rules for translations. Just remember when you guys are doing your rules of translations, it's just going to be, let's go back here, you have your change in x, you have your change in y, and you're always going to add it to whatever the current is here. Just remember that if it's a negative number here, you're still adding it even though it's going to work out as subtraction. So if you have like a -4 here, you take your original point, you're going to add -4 to it, which will act as subtraction. All right, I think that'll get you guys started on the homework assignment. The homework assignment will be listed on the note sheet that you guys got in class, and we will go forward from there. Try to answer all the questions or as much as you guys can of what's on the note sheet, and if you guys get stuck on anything, watch the video again. Cool thing about a flip lesson is you guys are able to go back and watch the video multiple times and go back over anything that you guys may have missed. If you guys are really stuck on anything, just make note of it on your note sheet, bring it up in class, and we'll get all that fixed up before we move on to working on the actual assignment. Yay, cool, congratulations, your first flip lesson.